Hi folks, this is PCSB Project. Today we're going to discuss Orange Pi 6's neural processing unit, which is one of the most powerful in the world of single board computers. We are going to install ModelScope, which is one of the most powerful collections of AI models and programming examples. We're going to install ModelScope on Orange Pi 6 and we're going to see how much resources we do need to do so. We also have an instruction booklet which will guide us with installation, but it is not the only tool that we are going to use. Orange Pi 6 can have up to 32 gigabytes of memory. And why I'm talking about the memory? Because memory is very important when you're doing AI models. Actually, 8 gigabytes of RAM is not very much, but we're going to see whether it is enough to run at least some AI models. So first, let's see all the functionalities that ModelScope can offer to a programmer. Installation, Model Hubs present itself as a humble directory, AI Model Hub. So let's see what's inside. You can see that there is not only a license, there are demonstrations, there are data sets, there are scripts, models, and also this humble requirements file. But it is also important, if you want to have all models operational, then it's not a bad idea to type pip and install and requirements and txt. So I've already done this, so I'm not going to repeat it. You can see that we have 4 groups of models: audio, compute vision, generative AI, and multimodal. If you go to compute vision, we can see that there are a lot of very interesting models, like the one that recognizes characters, the one that detects faces, and it is very interesting if you add your own test sample. For example, let's go to face detection. So we have a number of examples. What if we pick just the first one? So we have different kind of files. So when you start, it's not a bad idea to read readme. So you can say cat readme and md. So you get a basic idea what the model is about and what the example is about. And here we can also see that there is a C++ example included, but there is an additional requirement for running a C++ example. So let's first see pattern examples. There are 2 examples. First, inference NPU example is meant to be run by neural processing unit. So actually when you start it like this, enter. So it takes a little bit of time to start to actually to load all the information. I'm sure that it would be faster if I had an SSD drive, but unfortunately I only have an SD card, which happens to be 128 gigabytes, and then I have another SD card which has another 128 gigabytes, and I've somehow managed to pull all these models together to function as one model on one drive. As you can see here, we have times, so this is interesting. It actually shows how little time neural processing unit needed to calculate to do all these jobs. So you can see here it's also another measurement of time. And now let's try the same task with central processing unit with an NPU. So we're going to say ONNX and we start another program. So as you can see, it's almost 10 times as much. So though there are 12 cores, which are of course very fast, it's much slower to run AI on the processor. So let's see what kind of faces we would like to find. So let's go to test data and let's see what's inside. So we have 2 pictures. Enter. Here we go. So we have 6 happy faces and we want the algorithm to find each face. So let's see whether it's capable of doing so. So previously we already ran the algorithms, one with NPU and one with central processing unit. So we have the output directory here. Here we go. So we have 4 resulting pictures. So let's see the first one. Wow, do you see the squares around the faces? So each face is surrounded with a square. So the computer has actually beautifully recognized human faces. So it's very precise. And let's go to the next picture. This is a completely different picture in different postures, smiling or not smiling, but still very well centered squares around those faces. And now let's see if there is any difference whether you do this task with the CPU. As you can see, no difference on this picture. What about the last picture? It's also the same. So, but what about face recognition? So let's try it. So face recognition means first face detection, and then you have to tell who is on the picture. Here it is. As you can see, quite a lot of jobs. And now let's try the processor. So let's see whether it is any slower. So this is with the 12-core processor. So it takes some time to load, and then we're gonna see how much time it takes for the processing cores to do their jobs. So I'm still waiting, and it's finished. So, oh, we have another picture here. So let's see. Okay, we have 3 pictures. So then we'll also check the test data. So it's fun actually to have another picture that I've intentionally added just to have a sample that is not included with the library. And let's see this person. Unfortunately, we all know who it is, but the model has not recognized him. So why not? So if he was recognized, there would be his name on the square, but it is not. So Elon Musk is not recognized. And let's see what kind of other persons the model can recognize. Grab it. To see this, I'm going to enlarge it. See, Rachel, and then we have Ross, we have Monica, Joey. So all these faces are in the neural network. Neural network is pre-trained to recognize all these faces. But if you insert a random face, it won't be recognized, which is pretty much logical. And now let's see the next picture. They are in different poses, and they are also recognized. So the only thing that you would like to do with this application is that you would add Elon to the database. So this would be out of the scope of this experiment. So generative AI was moved to another SD card. It's about 40 gigabytes large, and this means that there was actually I was running out of memory space on the system drive. So I added another SD drive through a data key. And then I've copied this 40 gigabytes. We have large language models, we have image to text, we have text to image search, and text to image. So these are very interesting applications, but let's go with the first one. And now we're gonna run inference. So, okay, should be there a little bit. Okay, here it is. So let's run it. Let's see how it works. So it complains about a deprecation, but we have all the old versions installed, so it's gonna still work. We are actually in year 2025, so don't worry, it works. But if you're gonna run this kind of software with new applications, then it's clearly won't work. You see this writing? It says maximum similarity to a person, maximum similarity to a dog, and to a bird. So let's go and see the tests. And you see a person on a crosswalk. Okay, it is a person, it's a bird. So let's see what it says if it is a bird. Yeah, okay. What picture do we have? Yes, this is a bird, this is a dog, and yeah, this is a dog. So everything is right. So this last part of the video, I'm going to give you a few installation tips. First of all, it is very important before you start reading the booklet from the page 238. So this is how to use CIX Model Hub. Is to actually determine which kind of version of Windows you have. I suggest that you install the one that is available from the OrangePi's website. This is Ubuntu version 24.04. This version is directly covered in this installation manual. You can also install Debian 12 if you want to, but it has less pre-installed modules on it. So for example, this device AI processing unit would not be installed with Debian. So I actually, when I started my installation, I didn't know that I should actually read the instructions for installing Model Hub on Ubuntu 24.04. And then there are right away these paths. These paths are very important because otherwise the examples will not work upon installation. But look what I've got through. Actually, I've placed all my shortcuts or all my exports here. So this is the last part, and you can see how many of them are here. So you can also use this knowledge if it comes handy to you. I had to add this final path because I have split the AI model to 2 drives, and it's very important for the Python to know that it should not go to the actual path to a certain file, but it should also seek it here. So if it is on the auxiliary drive that I've added, that would be the name of the drive here, so this path. What is also very important to know is that if you are going to install AI Model Hub on a small drive, like I did, then go for those first installation option. So then go for this installation option. Do not try to go for the second installation option, which is using Git to download. As you can see here, this is the second method, because in this case you would need 150 gigabytes, and this is of course impossible to download on my SD card, which is unfortunately just 128 gigabytes. So I was very happy that I was actually able to download the whole library to this, and then it turned out that I had to split the library. I had to pull out the Generative AI, which is 40 gigabytes, and place it to another drive. And this actually saved me a lot of room on the primary drive to be able to install all the other libraries and requirements, as you can see here. So everything of this must be installed. For these versions that you can see here, we have NPU, we have different kind of libraries and everything. It is not exact, because actually I had to install a high version of NPU, not the one that was pre-installed, but I had to install version 6.01 instead of 5.11, and because certain examples would not work on the environment that I had. There is another consideration that is very important to make if you're installing. This is to have a virtual environment. You can have Anaconda, you can have a standard Python virtual environment, but if you try to downgrade the basic Python version on your Ubuntu installation from 3.12 to 3.11, you'll find out that terminal windows are not going to open anymore. So this would probably be a great surprise to you, so don't do it. You can only install these libraries to a virtual environment. Here you have instructions to install for installing virtual environment on a PC. This is the upper part, and the bottom part is installing the virtual environment on a ARM64 architecture based computer, which is also Orange Pi 6. So use this to install it. Okay, this is all we have time for this time. If you'd like me to make another video on installation, just write a comment. Tell me what you would like to see, what you would like me to discuss. And if you've liked this video, please press like and subscribe buttons, and don't forget about the notification bell. If this video brought you a new value, then hype it as well. See you in the next video. Bye.